Oh yeah.
So
Um,
just sorry, just a quick for the meeting recordings. It's TC39-TG3. It is May the 8th, 2024. We were discussing the signals proposal. Hopefully, we'll be joined by some of the champion group later during the meeting. We were talking about what folks here, what some concerns were with the proposal as currently written. And Matthew has mentioned the observable global mutable state, and that nothing in the spec right now has internal state that can be observed. And then Nicolo was asking for some clarification on that.
right. So, and anyone, if you remember better than me, please jump in. But my recollection is that I mean, the README itself mentions that there is some global state, and that global state is observable through some APIs like Watcher, and uh, and basically all the subtle namespace of the API. One of it is, from what I remember, like the current signal or some more current compound or whatever the name of that was, which gives you basically the reason why you're being called. If a compound is currently processing, like it's a sort of dynamic scoping, if you will. Like it lets you know in what context you're being called. But it's dynamic scoping, unlike async contexts. Async context, you need to have a reference to an async variable that you set to know that further down in the stack you're within that context. Here, it's just a pure global state. You're like, this is the signal that is currently processing. Um, and Watcher, from what I remember, allows you to get notified when one of the signals. So Watcher has a callback that gets notified when one of the signal it's observing is potentially dirty. I think by itself is fine, but I think they also have a mechanism to avoid food guns that during the callback, there is a global state that says we're in the process of notifying, so you cannot go and change a signal during that time, a signal value during that time. So basically a bunch of dynamics. It all reflects as somewhat dynamic scoping and directly observable values that change.
Okay, yeah, thanks. I understand. Okay. Yeah, I guess the one in Watcher is like to prevent infinite loops.
Yep. Oh, I understand the reason it's there. It's just
yeah.
I've built similar reactive systems where it's just like any other one of these how do you resolve cycles issues. I've built systems where the answer wasn't that it was on that you couldn't set a thing that's in the scope of things that have been changed, but you can't that if you do it drops. It basically cuts the cycle. It's sort of like a depth first search. If you encounter a part of your own tree, you just back off.
It's still global state because you need to know if the signal is already in your tree.
So if you set it up so that signals internally ignore a set if they're in the process of emitting a notification with a previous value, then intermediates do not need to know. So you do not need a dynamic scope system in that case. So that is something that we might concretely suggest.
Wait, then?
Yeah, it can be a local thing that each signal that knows, I mean, if the signal knows it's a trigger, it can be reset. What's a little less clear is that if you end up changing another signal that's part of your dependency tree at that time, because that signal might not have been notified to trigger the dirty notification. I mean, to be honest, like I am not sufficiently familiar with like all the usages of signals and also all the discussions that happen during signals. Where I'm hopeful is that after the plenary, the champions knew exactly what the concern was, and they mentioned they had ideas on about some of these things. So I'm hopeful.
Is this hope both for this watcher and the current signal, or like the way you describe it looks like the current signal is something much more difficult to solve because the global state, that's the whole purpose of that being exposed. Because like you cannot really pass it down as a parameter because you don't know what signals there are in the middle, right?
Yeah, I am honestly not sure how they would solve it. Apparently, some signal approaches in some libraries, they've realized that having global state like that is a problem, and some implementations of signals in some libraries do not use this approach. So maybe there is alternative approaches. I don't know. But yeah, and so if it reduces to even if it reduces to it's the equivalent of an async context variable. If you end up giving a way to observe the contents or the states of that variable through an API that you expose, it's like having a global async context variable that's shared and exposed. So it's not we can't simply reduce it like, oh, let's build it on top of async context. It's more complicated than that. Like you have to build it on top of async context and also make sure you don't root your async context in the global itself.
Yes. Another question related to Signal's proposal for like this group, which is more like again, still I don't know exactly how the Signal proposal works. Do you see any problem with like the Signal's graph crossing realm boundaries? Because like in Shadow Realm, you cannot pass a value, but you can pass a function that internally calls a signal, and so you create a cross-realm link.
Oh,
so signals crossing security boundaries is an interesting problem because they're reentrant. You have potentially mutually suspicious parties and different producing signals from different parts of the graph. And if there are watchers involved, then you have notifications running on this, having not only awareness of who's calling you, but also the ability to interfere with signals that are notifying you of your change. So like having a signals graph that encompasses mutually suspicious components, for example, components straddling a realm boundary, seems iffy. That's my intuition anyway. If it can be done in a way that doesn't have synchronous callback notifications and where the shared mutable state isn't observable, I think mutable state is tolerable if it is not observable. So like having the dirty check bit being encapsulated in a way that's not observable and not having synchronous notifications between signals.
My understanding is that synchronous notification is a requirement of the proposal.
So this issue about so I have a sort of a general computational model question. Is one way to think about what signals are doing is that it's trying to be, in the same sense that you can take functional programs and reduce their complexity method tremendously by memoizing, that similarly, you can think of what's going on here as you have a computation that naively would be expressed by recalculating. When you have a computed value that you just recalculated by doing the entire computation from the current state of all the component values, just the way you would do it naively if you just weren't worried about runtime. And then the whole thing about the invalidation bits and all the rest of that is basically trying to do an optimization on that to avoid recomputing things that haven't changed. Is that a valid sort of conceptual notion of what we're trying to achieve here, or what they're trying to achieve here with signals?
That is a basis for it, I think, except that they wanted to be able to have a notification when the dirty check propagates out to a particular terminal. There's Conall-Elliott's behaviors are similar in design to signals, except that
I'm sorry, what is similar in design to signals?
Conall-Elliott's behaviors, and then it's just
I don't know those. Okay.
The behaviors are very similar to signals per se. In fact, I think they might be close to identical. Watchers build on top of that, though. Signals, with signals, in the behavior literature, the general notion is that things may be recomputed when they are accessed, and the optimization for dirty bit checking and rechecking and recomputation is hidden behind that. But when we introduce watchers and the propagation of notifications, then that departs from behaviors. I think behaviors are consistent with the model that you described, Mark.
Okay.
And from what I understood, like the notification part is a core aspect of proposal. Because like if you have an app and some of your variable changes, you need to know that you need to re-render your app to show the updated values.
So
Yeah.
just to stretch my computational model analogy, if every frame you just recomputed your entire rendering naively, then except for performance, you wouldn't actually need to know that anything's changed, right?
Right.
Okay. So the reason why I'm starting with that computational model is that the naive form of that doesn't violate any object capability principles, doesn't violate any security principles. And that means that if you had a means of optimizing that where the optimized form was not observably different than the unoptimized form, except for performance, I don't, obviously, if I knew a way in which that was possible, I'd suggest it, so I don't. But in general, if you start with a naive model that doesn't violate any principles, and then the goal is to optimize it under the constraint that you continue to not violate any principles, then, so for example, if this thing about recomputing on every frame, if you can't tell that you didn't recompute on the frames where nothing changed, so it was as if you're recomputing all the time, that would be, that would continue to not violate any principles. Now, it might be that there's just, because of the nature of JavaScript, that this is just the wrong linguistic base it's not the right kind of language for such a transparent optimization to be able to be introduced in an unobservable manner.
I think it's not actually that far off from. Well, I don't know. We have to have signals champions here to see to ask the question of whether this is palatable. But I think it might be, on the basis that the behavior and signals layer of the proposal, omitting watchers, presumably makes it inexpensive to check the dirty bit or anything that is rendered on the cadence of an animation frame. And then also it's possible to only schedule animation frames when anything is dirty. So I think that there's a way to shape this proposal or a portion of this proposal in a way that definitely fits.
A portion, yeah, that's the problem. I mean, I don't think the champions are interested in anything that has a different shape than signals. Like any other alternative approach, such as execution memoization or whatever, is not.
Well,
I don't think.
With regard to what the champions are interested in, presumably the champions are interested in a proposal that has a possibility of advancing, which
No, the proposal, the champions. Let's be clear here. The champions are interested in the shape that signals that has matured in the ecosystem for some time, and I am pretty certain that if TC39 is not the venue where they can advance this, they will advance something in of that shape in another venue.
I see.
Do you think
Okay.
there is indeed that risk that it would happen somewhere else, or they would just say, okay, then we'll keep doing this in user land? Because like signals are currently already implemented in user land.
And they've been in the wild for a long time.
Yeah, I mean, it's worth keeping in mind, and this came up in the Signals community call last week, well, because I brought it up, which is that the observables proposal is being undergoing introduction via a different standards venue, specifically W3C.
This is the observables proposal that Jafar and I were championing?
I believe it is a spiritual successor to it. Yes.
Yes.
I
think.
Yeah, so the community has coalesced around this approach already, and so there is not any appetite into going into a different approach.
Tragically, all of these are part of a coherent story that ideally is told in one specification. Like signals serve for those who don't know, I wrote a paper, well, not a paper, but an essay of sorts called General Theory of Reactivity, time ago now. And like the crux of it is that these different reactive programming models do form a coherent story together, and each of them fills in a different slot in a number of like temporal and spatial dimensions. And like plurality or arity and terminability are two of the things that are important for that. And observables are in that reasoning, iterator and observer are duals. Like observer is the synchronous emitter version of the iterator being the synchronous consumer. And it makes sense for them it makes sense for observers and iterators to exist within the same specification because they are duals and should have analogous shapes. Those shapes fall out by implication from the generator protocol. Where signals fit is that they're a value that changes continuously over time, but does not have a terminator, right? So you don't need iterator protocol for a signal. It's just a value that changes over time. And the combinators for computed signals are that follow from that. So I think signals have a place. I am less sure about watchers. It might be possible. It might be possible to build watchers, but my understanding is that watchers are entangled within the subtle namespace with signals in ways that I don't think we could accept, for the same reasons that we don't yet, at least, make the state of a promise synchronously observable.
We are right at the half-hour mark, eagerly anticipating the arrival of the one signals champion who is committed to showing up.
The observables, just the observables that Jafar and I were championing long time ago are very, very different than generators. And I don't remember what all the motivation was for why they were so different.
Just want to be clear, is this the same? Yeah, it is. Okay. Sorry, I should explain what I was trying to say, which is I just want to make sure that what Mark is referring to is one and the same as the proposal that I linked, the first one that I linked, TC39 proposal observable.
Is it?
Yes.
Okay.
And then, but my second link is the link to the, I guess, was what was referred to as the spiritual successor, which is that proposal being effectively taken up in the web interoperable community group.
Okay. Does anybody remember why it stalled or failed in TC39? Because that's also something I don't remember. I know I didn't fight for it real hard. And I know that at one point, Jafar left Netflix, I think it was. And when he did that, he also left the committee. So it might have just been lack of momentum, but that lack of momentum, I mean, it sounds like that there was momentum. It just wasn't at TC39, which is, in that case, a terrible shame. If that was the only reason.
Yeah. Yeah, this is mentioned a bit in the proposal, the new version of the proposal itself, and then as well as a issue Dan filed about historically being held back in TC39 because nobody presented a vision that solved the issues that tied into cancellation, as well as cooperating with the folks, our friends from WhatWig for DOM and HTML. And then I think Ben Lesh expands on the choice of venue a little bit in the README or somewhere thereabouts. But I think that generally it focused around the use of the eventing APIs that are native to the DOM spec, if I'm not mistaken.
Okay. So, yeah, I remember when cancellation stalled out at TC39. And then when it reappeared in W3C, it got entangled with web-specific event stuff in a way that just seemed like it was a poison pill for being able to bring it back to TC39.
Yeah, the withdrawal was unfortunate, and I think, pretty unnecessary. I do think that there are some significant problems with the W3C, or sorry, with the HTML one-way cancellation API that limits its usability, and that's something that we could potentially build off of.
So
Also,
Dan,
for observables, if you were talking about observables,
we were, yeah.
the idea to have observables where it doesn't return the subscription, but where it takes a cancel token as a parameter, that's kind of untested. It was kind of requested from the by Dominic, but I'm not really convinced that we should use this kind of mechanism for everything. I think there's a correspondence between disposal and cancellation. I know this is controversial and some people disagree, but I think cancellation is disposal, and we do have a disposal API, and I think we should be working towards the kind of correspondence between the two. The disposal API that we have doesn't separate the capabilities of observing the disposal versus disposing, which abort controller does nicely. There's also issue about the naming. Many people find the concept of an abort controller kind of distasteful, given current very bad legal things going on. So I think we should continue working on this with signals and thinking about
Dan?
Dan?
Dan, are you there?
If you can hear us, we cannot hear you.
Well, we got teased by a minute presence of Dan.
Oh, and now Dan shows muted.
Is it Dan? Are you there? Is connected to audio and joined from a mobile device.
No.
While we're waiting for Dan, I have a recollection from some of the TC39 discussions with Jafar. One of the things that struck me is he was very responsive to feedback he was getting from other committee members, but one consequence of that is that the proposal, the details of the proposal kept changing rapidly, including several times within the context of the single meeting. Because he was adapting as people gave him feedback. And I think a lot of people kind of took a step back and said, okay, we're going to wait for this to stabilize. And then when Jafar stopped participating in TC39, when he left Netflix, I think it just kind of disappeared from people's consciousness. And that's probably very unfortunate because, it just it just fell on the floor.
See, Dan is back. Do you want to test your audio, Dan? Can you hear us? You're on mute currently.
hello, can you hear me?
Yes.
Okay, great.
I don't think we got anything of what you were saying before. You started to say something about signals, and then you cut
okay.
out.
So I'll restart at the signal part. I think signals and promise cancellation are deeply parallel to each other. There's a tree structure here where when you have a call graph or like a call tree of actions, you know, that are invoked by async functions, and you want to cancel, you want to be able to cancel any kind of subtree. You want to cancel where you are, but if there's a surrounding operation that you kind of don't own, you don't want to cancel it. So you want to be commonly doing this forking operation, and where you have a sort of parent abort signal, and then you make a child abort controller, and you OR them together, so that any child operations are canceled by either one of them. In reality, you kind of would prefer, I think, to have this cancel token be in an async context variable. That would be a lot more convenient in practice to use, because passing around a cancel token is too difficult, and actually dynamic scoping is perfectly appropriate for what you want semantically, because you just want it to go down the call graph, and you want it to be restored across a wait. So it's kind of the perfect thing semantically. All of this corresponds to signals as well, where computed signals, unlike async functions, they're similar in that they're like a piece of computation that happens later, but they're different in that async, or in particular await, is single pass, whereas computeds are multi-pass. They can multi-shot. They can be called multiple times. So in particular, when you have a render tree, when you have like a tree of widgets that may have some computations or conditionals or loops inside of them, you sometimes need to rerun some children. Sometimes you need to dispose of things. You generally want to dispose of a subtree and recalculate a subtree. And I think this is exactly the same. This disposal of the subtree is exactly the same as what we want from promise cancellation, with the difference being that it's kind of multi-shot. That in particular, you'll be restoring the parent cancel token multiple times to recalculate the, re-execute the children. So I'm very excited to work on this project. I think this is, just as important or fundamental, or even more so than signals. In web frameworks, people generally have to tackle ownership before they tackle getting the reactivity mechanism to work correctly. But they're both really kind of fundamental computation systems that have like a right answer. So I think they're both very amenable to being, language primitives.
What do you mean by ownership?
Ownership. So in ownership is the flip side to disposal. Ownership is sort of the unit of stuff that you're disposing. You have an owner that represents sort of the abort controller, the capability to destroy this thing. So you can, when you're a child of something, whether it's rendering or whether it's running some async function that you want to be cancelable, you kind of want to register your action on some outer list of things that will be disposed if that owner, needs to cancel itself or to clean itself up. Does that make sense? Maybe those aren't the best terms to use, but that's the term that I've been using.
It's not a terrible term. Certainly having a term for being, where the relationship is the right to dispose. I have a right to dispose that thing. That means that I can render it useless to others. Calling that ownership doesn't strike me as terrible.
Yeah, and I guess in these sorts of cases, by construction, the thing that we're talking about disposing is just of use to, in that particular tree-shaped pattern. Well, I guess that's not really true, because when you have, for example, a fetch that you're awaiting and you have this outer thing you want to cancel it, you could have sent the promise to someone else. and then it'll become useless to them if it becomes canceled, in time.
Right. It's yeah. There's multiple users of it, but the right to render it, cause it to become useless, is distinct from the ability to use it until then.
Yeah. So this concept of ownership, or actually avoiding ownership and supporting multiple users, is really key to the design of signals. In particular, computed signals don't have to have an owner. Computed signals can be read by whoever, and they live as long as they live, and then they can be garbage collected. And this differs from some signal implementations, which do maintain ownership by the time that they were allocated. It turns out to be very useful to have, in general, computed signals being independent. It really helps with the view model separation that we're going for in the first place.
So let me try to just raise what to my mind is sort of the big question, that which is with async context, you and Justin and I'm sorry, I'm not remembering the name of the main person. Any case, who are the main people on async context? I'm just
Justin, Cheng Jung, and Andrea.
Okay, good, thank you.
But I'm keeping track of it and trying to help where I can.
Yeah, okay, good. So in any case, you guys just did a incredible job at, on the one hand, looking at the things people were doing that was sort of in that conceptual neighborhood, and realizing that there was that people kept sort of reinventing aspects of it, and that there was a need for something general and uniting there. And on the other hand, realizing that done naively, it violates all sorts of locality and security issues, in particular the normal objections to fluid and dynamic scoping, and well, specifically on dynamic scoping. And in any case, you just did this incredible job at trying to come up with something, and in fact, coming up with something that came as close as came very close to satisfying the security requirements as stated, and in fact came so close that it led us to re-examine the nature of the security requirements as stated, and the nature of your violations, and to judge that you'd actually, you hit the sweet spot. You actually preserved the security properties that were actually at stake, while creating something that satisfied the design objective that was paved, that was cowpathed by the previous system.
Right.
So,
In that case, I think Cheng Chung's initial proposal did a very good job of achieving all those security goals. But it did take a while to analyze it. And I do agree with what Matthew presented in the last TC39 meeting about how the current signal proposal doesn't make the cut with some of the subtle APIs. We have to revisit those.
okay, good.
And I
good.
hope we can. So I hope we can do this same kind of bringing the ecosystem together approach with both signals and ownership. I think they're really important topics, and
okay.
just because we have first stabs in the general area with observables and abort controller, I don't think means that the area should be off limits to us. Fundamentally, this isn't true everywhere, but it is true everywhere that community outreach is really hard. It's just a huge amount of work. And if that work isn't done, and we say, you can't do anything else because there's already something that's there, but if it doesn't actually solve the problems that people are repeatedly solving, well, we still can work on it. So I think the important thing is for us to actually get the community together, to get to really have an understanding of the problem space and what could solve it. Because today, like, even though abort signal exists, it's not what frameworks use for destruction. Nobody uses it. It's just kind of too awkward and noisy. Maybe they use it for some limited things. Maybe they help propagate the abort signal so that you have access to it when you're going to call into a web API that can be canceled. But it's not generally used as the destruction system that in this general way that I'm mentioning. Even though all web frameworks have a notion of that.
Okay, so let me just follow through on that and get confirmation of what I think I'm hearing. Just let me restate it, and you can tell me whether I'm getting it. That with regard to cancellation, signals, possible unification with disposal, that there's an opportunity here to do something that satisfies both the conceptual needs that the existing systems have kind of shown a need for, such that by changing APIs, like with async context, they could unite in a new system, and that like async context, and maybe using async context, it's constrained to satisfy the general security invariants that we're constraining JavaScript in general to follow. And so first of all, so the particular thing I want to get confirmation on is you're not stuck on particular current APIs and compatibility with those. The point is to get something that satisfies the conceptual need, and if people need to change APIs to use the thing that emerges from TC39, that's within the goal.
I can say for sure that for signals, that's in alignment with what we're doing. We're not really aiming to provide a really perfect surface API. We expect that there are going to be all kinds of wrappers and encourage that, but we want to find the underlying semantics that could be shared.
Okay,
and
good.
Respecting these regularity properties that we've been maintaining will be really good, I think, even to ensure things like implementability. That things are often more implementable if they don't, if they don't do certain things in a messy way, it often ends up being easier to maintain.
Good.
Depending on the case, but yeah.
Good. So that was actually the most important question that I had. But just going from there to this very specifically, part of the signal proposal is very much this dynamic context, very much a dynamic scoping kind of thing. And it's not, as proposed now, built on async context as the means for providing the dynamic scoping.
Yeah, that's right. So in particular, computeds are synchronous. The computed signal goes into its computing state and leaves the computing state without yielding to the event loop. And so it's sort of never valid to restore the computing context like that. We've been hoping we could find some sort of notion of async computeds, but we haven't found one yet. And this has been, this is kind of consistent over the development of lots of different kinds of frameworks. So I think auto tracking is sort of its own thing, unfortunately. I do think ownership should be tracked by an async context variable. And, but basically, for your computing context, you really don't want other things to be capturing and restoring that, because you kind of want to draw close to being computing something. It doesn't really make sense to restore it later once the computation is already concluded and the answer has already been returned to the caller. We have a number of fields of execution contexts. So it's not really totally new to have another one. Obviously, would
Yeah,
be better to have fewer,
but currently the execution context doesn't. You can't observe its state. It's an internal construct of the spec that the JavaScript program cannot really observe directly.
So you're right that current computed is too powerful. We're going to work on revisiting the use cases and figuring out some other mechanism that doesn't do that particular thing.
Yeah.
I think in a lot of respects, current computed exists merely because async context or the sync version of it weren't available to us.
But even
prototyping.
even if you have it, or even if you have something like that, the main problem, even if you build it on top of async context or a sync version, or I mean, at the end of the day, it's the same thing. If the variable ends up being something in your, if you have a single variable that's in your global states and you offer APIs to observe the contents of that variable, you basically end up in the same problem. You have a global mutable states that you offer observability into.
So
Yes.
we're already convinced, Matthew. We agree with you. The one example of a use case that I wanted to handle here was what some frameworks call a write barrier, where within a particular computed, you're not allowed to write to any signals. You could implement this with current computed by having a bit on the computed that says whether you're in a write barrier, and then you have a wrapper around set that checks whether that's the case. But there are a whole lot of other ways that it could be implemented as well, either with something that's built in or with something that's implemented in JavaScript. But I did see that Angular implemented this by looking at a flag on the signals, and I was kind of wary to take away too many things at once. Another source of kind of entanglement is the introspection API, which Shay has pointed out means that nothing is really private. But there was a piece of your feedback, Matthew, that I was confused by, which was saying that having a bit to indicate whether it's notifying and then disabling reads and writes within that might be a communication channel. And I don't see that to be the case at all, because so first, this is a very, very important property of the proposal, that you cannot read signals within the notify callback. This is important to preserve the glitch-free property. Now, I wish we had more formal definitions of what we meant by these things, but it's a sort of sense of consistency of the whole signal graph and not observing things in intermediate states. This single bit, I don't see how it communicates any particular information. Maybe you could expand on that.
Yeah, so I think this one is about the fact, like, while a notify callback is being invoked, if the notify callback cannot go, so the idea is that to prevent it from touching any other signals. But I think that the problem is scope. The notify callback, the watcher, is associated to a set of signals, which at the end of the day, you want to prevent it from touching any signals that might affect any of the signals it's currently watching, right? Or is it any signals in general throughout the whole system? What is the scope of the write barrier, basically, or of the read
it's definitely
barrier?
broader than the set of signals that are inside of the watcher, because there may be dependency graphs. Right. Checking whether the edge exists, it's really hard for me to understand why we would want to weaken this condition. It seems like it would add a lot of complexity. And also remember that the shape of the graph is always kind of changing. Every time a computed runs, it reestablishes what its dependencies are. So I would be wary of weakening the condition, but maybe if there's a good reason, we could consider it. I just don't understand the reason yet.
We're about out of time. Several of us have a meeting that starts at 11. I would love to continue this conversation. I believe that we're, quite far from having exhausted the topic. But I mean specifically the topic as discussed at TG3. How does next week look for everybody?
Great for me. I'm happy to continue on this topic.
Okay, great.
I should be able to be on time next week.
Excellent.
Awesome. Great. Thanks, Mark, for time checking. Yeah, hope to see everybody next week.
Great.
Bye, everyone.